statistics, we do this. As you can see, in secondary, to run bar graph, we do this, as you can see too. Thirdly, to run heat map, we do this, as you can see on the screen. Fourthly, to learn kernel density plot, we do this, as you can see on the screen. And to run box plot, we do this. And OLS regression, we do this, as you can see on the screen too.
Yeah, to continue with, as my friend colleague has already done a part of this. So we have actually learned some graphs, seen the results. So yeah, we did learn some regression here, or less regression that is. Now one of the tasks that we also use and that we also considered to learn is some diagnostic. So learn heteroscedasticity. We also learn multicollinearity and also uh, to check for misspecification of values in our dataset. So to do that, we just write the command, which is estate, that is for us, estate head test. So when you do that, you see that it shows us our p-value 0.00 and the chi-square of 129.54. This shows that we have a p-value of less than 0.05. Therefore, as our variable states that there is no heteroscedasticity, we fail to reject that. This means that our data has presence of this heteroscedastic data. Therefore, we also learn multicollinearity to check if there is any collinearity between the independent variables, that is education, experience, and tenure. So to do that, we also learn the same command, state VIF. Now VIF shows you if VIF is less than 10, that is amongst the independent variables that we have, experience, tenure, and education. It means probably it's far from 10. It's much less than from 10. It means this our data has no presence of multicollinearity. But if it is close to 10, that is among maybe 9 point something, 8 point something, 7, above 5, it will show that our data has multicollinearity. But in this case, you can see from here, from our observations, most of our observations, even the mean VIF is 1.3. This shows that there is no multicollinearity. So we continue to also learn some uh, we also continue to run logic tests. So For us to upload the data LBW, we run the command BW and just copy it into the command bar. Web use LBW. This will tell Stata to check into the web and upload the data. And also at the same time, we also learn logit model to check. Now, if you do that, automated data is downloaded and also it will learn logit model. So from our observation, you can see that if a woman has a higher chance of having as a higher probability of increasing birth weight, you know, if the woman smokes. This is by showcasing you can see the intercept, I mean the coefficients. Smoking has a coefficient of 1.09, and also if you, in accordance to age here, it shows that a woman, probably if a woman maybe decreases age by maybe 1 year, there are less chances of that woman having a birth weight. So this is how, this is how our results tell us. This is what the results tell us. Now, we are also asked to learn the margin. So, margin, we did to learn the marginal effect, just type marginal, margins, comma, DYX, and then star. What it means when it's tell it to say star, it means it will learn the marginal effect of all of this. But assuming we just wanted to learn more for one, it means we would have specified the actual variable, let's say age or anything. But in this case, we'll learn the marginal effect of all the three independent variables. Now you see from our observations that uh, every decrease in age, every 1 year maybe decreases in age, also decreases the chances of a woman having what birth weight, but that is 0.7%. The same way we talk of less and also smoking. But in terms of smoking, unless we increase the chances of the woman having a birth weight by about 10% for race and 21.8% for smoking. That is based on our observation. Yeah. So continuing, we are also taught to run probit model. From observation, you observe and also run directly the margin. The same way here, probit model, you see that there is a latent chance of the woman having birth weight with sorry, this is not about now, but we're dealing with auto data. Now, here we are taught to analyze, learn a probit model, check for falling using what? Mileage and weight. So, from observation, you see that if a car has a less weight, it means there are probably less chances of that car being fallen. And also, in the same way, if a car has a latent, has a mileage of has a less mileage, there is a lesser chance of that is maybe we talk of 10.3 or 10.4% of that car being what? A foreign car. The same way, even from our results, it just relates with what the probit model shows us. So that's how we do about learning probit model. And also, that's the end of our question in terms of analysis using stata. That's the end of our video. Thank you.